For our next question, we're going to graph the curve y equals negative 2 sine of 3x minus pi over 2 plus 6. We're going to graph one cycle of that, and it looks like this. Now you might wonder, how did we get there? Well, what we did is we determined the parent function. We then determined the equation of the axis, the amplitude, the phase shift, the period, and then we stated the coordinates of 5 points. And we graphed, remembering to properly scale the x and y axis. And in this question, we're answering C. So, first thing we did is factor the 3 out of the argument, and we get 3 bracket x minus pi over 6. From there, we see that our parent function, for our purposes, is going to be y equals negative sine x. It's a sine curve, but the leading coefficient is negative, meaning we're going to use a negative sine x as our parent function. The axis is going to be y equals 6, but that's given by the c value in the question. And our amplitude is going to be 2. It's not negative 2. Technically, the amplitude is a distance from the axis of symmetry to the maximum or to the minimum height, and distances are positive. So our amplitude is positive 2. Now, looking at the negative sine curve, the parent function, we see that it begins on the axis of symmetry, but it goes down, then up, then up, then down. It's a reflection of the curve y equals sine x in the x-axis. There's y equals sine x. Y equals negative sine x is a reflection in the x-axis. So, that means that we begin on the axis of symmetry, and so the initial y value is going to be 6. But from there, we're going to go down 1 amplitude, down 2 units to 4, back up to 6, back up to 8, and then back down to 6. We have our y coordinates. Next, we look at our phase shift. In this case, the phase shift is pi over 6 radians to the right. We got that from here. So pi over 6 units to the right, meaning our initial x-coordinate will be pi over 6. Our period in this case is 2 pi over 3. And you might wonder how we got that. It's because the period is always 2 pi over the absolute value of k, and since k equals 3, our period is 2 pi over 3. That's a measure of the horizontal length of one cycle. Now, since we're looking for 5 key points, we're going to divide our period into 4 equal intervals. Why is that? Because when you have 5 key points, 1, 2, 3, 4, and 5, you really have 4 equal length horizontal intervals. So what we do is we take the period of 2 pi over 3, we divide that by 4. In doing some fraction work, we see that ultimately every one of our horizontally from one point to the next will always be pi over 6 radians. And from there, knowing that our initial x value is pi over 6, from our phase shift, and knowing that we always add pi over 6 radians by dividing our period by 4, we see that our first x-coordinate will be pi over 6, but then after that, we'll have pi over 3 as our second x-coordinate, pi over 2 as our third x-coordinate, because pi over 3 plus pi over 6 ultimately equals pi over 2, just using relatively simple fraction work. Pi over 2 plus pi over 6 is 2 pi over 3, and finally 2 pi over 3 plus pi over 6 is 5 pi over 6. Using those 5 x-coordinates and our initial 5 y-coordinates, we get these as our 5 points. Now, we need to know how to scale our x and our y-axis. Scaling the y-axis is relatively straightforward. We have fairly simple integers, 6, 4, 6, 8, and 6. So I propose we use 1 as our scale on our y-axis. On our x-axis, though, it's a little bit different. We're measuring irrational lengths. And so pi over 6 is our initial value, and we can see that our lowest common denominator there is 6. So I would propose using pi over 6 as a scale on our x-axis. So coming over to our curve, we see that we scale our y-axis vertically 1 unit per vertical square and pi over 6 units per horizontal square. And then we're able to plot our 5 points and draw the best sine curve through those 5 points that we can.